All right, hi everyone. We're going to go ahead and get started because we're going to talk about building applications that can massively scale, but unfortunately our time together is fixed at 60 minutes. It cannot horizontally or vertically scale beyond that. My name is Sean McKenna. I'm the lead PM for the Azure Kubernetes Service.
I'm Atul. I am a PM in the Azure Pipelines team.
Oh, hi there. I'm John Stella. I'm a PM working on Azure Dev Spaces.
So I figured we'd start off with a little bit of why we're here. And this is not the existential version of the question, although we can talk about that afterwards if you want. But why are we in this room in particular? How many people heard all the buzz and the hype around Kubernetes and then got there and found it was really, really hard? Anybody? You're like, you got there and you're like, this is what everybody's talking about? This is like very, very complex, right? I thought that this was going to be the awesome development solution that made it really easy to build these massively scaling applications. Like, really, where is all this hype coming from? And so the reality, and this is not just Kubernetes in Azure, but Kubernetes in general, and frankly, just building containerized applications and microservice-oriented applications is hard. And we sort of have to acknowledge that fact as a starting point, because then it becomes the basis for starting to come up with a solution. And so what we're going to talk about is how can we make it, first of all, easier to get started, right? So you hear all this buzz around Kubernetes, you want to just go get your feet wet, right? How do you get to kind of 0 to hero in 5-10 minutes? So how do we get that going so you get a little bit of momentum? And then as we start to think about taking it from there into something that's a little bit more real, getting some DevOps practices set up, setting up CI/CD pipelines so that I can make it actually a little bit easier. And then once I'm really up and rocking and rolling, how can I get a bunch of different teams, because this is kind of part of the idea of microservices. I've got multiple teams that are working together to build this larger business application independently. So how can we actually deal with that? So that's why we're here. Hopefully that's why you're here. Otherwise, maybe you want to check out another session. So let's kind of recap. We've been talking about microservices. The industry's been talking about microservices for years at this point. So just as a refresher, really, the value proposition is, whereas in a traditional monolithic application, you have this, effectively single binary, single monolithic application that everybody is working on together. Well, you potentially got dozens or hundreds of developers working on this same application, which makes it very difficult to make changes to it. Certainly makes it difficult to scale, right? Because you actually have to scale it at that big monolithic level. And so the idea of microservices is break it down into these smaller components that can then be deployed independently, can be scaled independently, and upgraded independently, and really enable multiple teams to work together in harmony. So that's kind of the idea. But again, it's hard, and we'll get to that. Now, if we take that as the basis of what we're trying to accomplish, and we look at Kubernetes, actually Kubernetes and microservices is a powerful combination, right? So there's a few reasons for this. One is everything runs in a container. And so the nice thing about containers from a microservices perspective is that everything is packaged together and it's all abstracted. So as somebody that is deploying containerized applications as a sort of an operator or DevOps workflow, I don't actually need to know or care that this container has .NET inside, and this one has Java, and this one has Python, or what have you, right? To me, they all just look like containers. So the fact that Kubernetes is exclusively container-based is actually quite nice from that perspective. There is built-in service discovery, so when I build a Kubernetes service, I get an entry into a DNS that I can then use to resolve as I'm doing this cross-service communication, which is nice. I can do this very granular container-level or service-level scaling, which again gives me that ability to manage those pieces independently, which is nice, and I can then isolate those things from a resource perspective and a namespace perspective. So again, a nice kind of segmentation of those individual isolated services, and I can tie all of that into role-based access control. So Kubernetes actually, once you get up and running, so from a operational perspective, is great for microservices. But as a lot of you have probably found as developers, it can be very challenging, right? And there's a bunch of different hurdles to getting started, right? So there's a whole bunch of concepts, which again, most of you have probably gone through this experience of like, okay, let me go quickly search Kubernetes and start, oh my God, a pod and a deployment and a replica set and a service and a, and on and on and on and on. And so there's a lot of concepts that just kind of hit you in the face before you even get started. Then, frankly, while there's benefits to it being exclusively container-based, it does make it a little bit harder to get started, right? Because everything has to be containerized before you even can get it up and running and deployed into the environment. So that's a hurdle. My goodness, there's so much YAML, right? And like all of those concepts that you go and read about, okay, how do I actually deploy this? Oh, okay, I'm handcrafting this YAML all over the place, which is just quite onerous as a way of getting started. Print line debugging, remember that? We're back. So if, a lot of people in here are probably quite happy with, what they've had in Visual Studio for the last, 20, 25 years in terms of ability to debug, and then you come into this containerized world and Kubernetes kind of world, and it's like, yeah, write everything out to standard out and standard error and go dig through the logs, and best of luck to you. And so that's not necessarily awesome. And then, even after I get through all of that from a getting started developer perspective, okay, now how do I actually go transition that into something that I can make real in terms of CI and setting up an automated pipeline to deploying that into a production environment. So lots of other challenges probably. This is just the tip of the iceberg in terms of things that you've probably run into in trying to get started with Kubernetes. So really our goal in Azure and Microsoft in general, given our heritage with developer tooling and developer productivity, part of what we're trying to do is make it easier for developers to go build those services that can then take advantage of all the great capabilities that Kubernetes has to offer from a microservices perspective. So we're going to talk through today some of those tools and how you can leverage them to make that a lot easier. So with that, I'll turn it over to John.
Thanks, Sean. So there's a few ways that we've thought of just improving the ramp up of a development team onto just feeling productive again in this new world. So just a few things just to be able to get started. One is just to be able to have a minimal local machine setup rather than a whole bunch of disparate tools that you have to set up and get working together. Just be able to reduce how much you actually need to set up. The other one is there's always a set of new assets that you need to now add to your source code. You've got your code, but now you have to containerize it. Not only that, you need to actually come up with the Kubernetes YAML to actually be able to deploy and so forth. And then more than anything else, just be able to provide a familiar experience. A familiar experience of being able to load up a project in Visual Studio, being able to hit F5. There's something about the productivity of being able to just run your code, run it again, hit a breakpoint, see what's going on, all before you commit your code. Okay, so that's something that we're all used to, and don't mess with that. Okay, so what I'd like to show you is a demo that kind of pulls that together. I'm just showing here that I've got the Azure portal open. The very first thing that you would need is an AKS cluster. And the idea here is that you work directly against that cluster. And it's just managed. It's easy to set up for you. And then later on, we'll get into, well, actually, now that I have a cluster that maybe I can share with my team, how can we all work together? But at this point in time, I've got a cluster set up. And then I come over to a blade here that's called Dev Spaces, and I can turn that on. And what that is basically saying is I'm using this cluster for development purposes and enable the right features for me to be able to have a smoother developer experience with. Okay, so that's something that you can just turn on. And let's just start right from scratch. I've got VS Code open here. Of course, we support Visual Studio 2019, 2017. It's actually just built into VS 2019. In the case of VS Code, you just install an extension, the Azure CLI, and you're on your way. So that's all that you need to get started to set up on your dev machine. And I literally have this open on an empty folder. So let's start here. So how many .NET developers do we have here? Just only a few. OK. All right. So I'm going to create a brand new .NET web app, like so. And just to be able to then connect to that AKS cluster that I have in my Azure subscription, I run an AZ command, AZ AKS, use Dev Spaces. And before I do that, let me just list the Dev Spaces that the clusters that I have. So AZ AKS, use Dev Spaces, pass in the resource group name, pass in the name of my cluster. And this is going to go off and try and connect and pull down the information I need to be able to develop against it. And you see right from the start here, the cluster that I'm connecting to, you will see that there's default, and that's a namespace, and then there's a tool, a bunch of names there. And you can actually see that this cluster is actually not just used only by me, but it's actually used by my dev team. And we'll get into that a little bit later on how I can use that. But for now, I'm going to choose my namespace there. OK, so now that I've just got a very new web app here, I'm going to run a command over here. And this is part of the Dev Spaces extension for VS Code. That's just going to prepare a bunch of configuration files for me. One of the questions it asks is, will this service have a public endpoint or not? It's a web app, so I'll say yes. And off it goes. Now, it's actually generated some things for me just to be able to get me started. It's added some Docker assets in here, so I have a Docker file here. Perhaps more scarily, it's added a charts folder. Now, a Helm chart is really useful in many ways of being able to templatize your Kubernetes deployment settings. But there's a lot of files to get through, and we just set you up right to be able to start from scratch. Of course, you can go in and modify these files. They're yours. You check them into your repo, and you develop with them. The other thing it's set up for me is a VS Code debug configuration over here. So all that I need to do up here, I'm connected to my cluster, and I just hit F5. And I hit F5. What's going on? Demo God's got me right on. Here we go. OK, it's kicked off. So when I do F5 from VS Code, what it does is you're seeing here some of the output coming through. It synchronizes my code files that is in my folder up into my AKS cluster. And it actually then starts to use the Docker file and the Helm chart that I have in my repo that I own to actually go off and build that container image for me. And you see that it's actually running through the steps over here. And soon enough, I'm actually going to have a running container. And you see the public URL that it gave me that I can use here. And my debugger is attaching to that container, which has just been built and is running in AKS. Let me just go back to the URL here. And you can see that I've got my app now up and running. Now, the kinds of things that you would expect to be able to do is be able to hit breakpoints. But one of the things that we really wanted to do is just be able to make that inner loop experience as seamless as possible. So I could go in over here, maybe go over to one of the pages here. And let's modify. So you could say, all I need to do is code. I can save my file. and refresh. So I'm going to go over here. Remember, this is a local file that I've got here. I just save that code edit, and then over on here, you can see that I've got this experience where I'm just able to modify some code, but I don't need to tear down the container, rebuild the container image, redeploy it to Kubernetes. For these kinds of very frequent developer tasks that you do while you're trying to figure out, is this a bug? How can I troubleshoot this? You're iterating on your code fast. You just want a seamless experience to be able to do that. So at this point, I'm just going to leave it at that. Hopefully, you've seen how easy it is to just be able to get your code containerized, set up with some basic Kubernetes YAML, and then be able to have a experience where you just be able to F5 in VS Code or Visual Studio and have your code running in AKS.
Right?
Yep.
OK, thanks, John. So we talked about the complexity around Kubernetes, how you have to actually learn Kubernetes, Docker, Helm, kubectl, all the different tools. And then now we are going to talk about CI/CD. I mean, already there was a concept count overhead, and now we are going to throw in some new concepts to the mix, right? And anyway, setting up a CI/CD pipeline on day one is a tough task. You basically choose a tool that you want to use for CI/CD, and then you go and open up the documentation for that. And it has a long list of steps that you need to perform. For example, it will say that you have to work in 2 different interfaces, go to interface 1, generate a token, then copy it, and then paste it into interface 2, and then paste it in a particular place, and so on, right? I mean, it's a long list. And let's say you were patient enough and you actually were able to set up your pipeline. Now, you run it, and you actually end up with an error. Now, what you do, you actually open up another document, which is a troubleshooting document, and you try to find out how to fix that problem, right? And what we have seen is this difficulty is actually one of the biggest blockers in adopting CI/CD practices. And it is even more amplified when it comes to Kubernetes and containers because of the learning curve involved. So what do we want to actually do? I mean, we actually want to help the developers take a GitHub or Git repo and then take it all the way to Azure Kubernetes Service and then have it up and running there, right? We want to actually lower the bar for Kubernetes CI/CD so that all the customers can actually use Kubernetes and be successful. So with that in mind, we have actually developed this streamlined getting started feature in Azure Pipelines, which actually gets you from a Git repo to a Kubernetes cluster with an app running inside it in just few steps. So I'll just give you a quick demo of that, live demo of that, and then I'll take you into some sort of a deep dive into what actually goes behind the scene and how we actually set it up and what are the best practices that you get out of the box by default. So I'll switch to my machine. So I have a similar app that John showed. Actually, this Docker file is generated by using Dev Spaces. And this is a .NET application again, and it has a Docker file. That's the only prerequisite that we have right now for you getting started with Azure Pipelines. So here, I have pipeline, Azure Pipeline. I'm in the product, and I hit New Pipeline. What it's going to do is actually going to get me into this wizard, right? So what you see here is that it's asking me, where is my code, right? So I showed you that my code is in GitHub, and I've already connected my Azure Pipeline with the GitHub account that I have. So let's select GitHub. Now, what it is going is actually going, and it's going to list all the GitHub repositories that I have in my account. And it's actually listing them by the activity. So for example, I contributed some code to the document of Azure Pipeline, so it's showing that up top. But I also have the .NET app that I showed you. So let's select that. Now, in this step, we are doing a few interesting things. We are actually trying to analyze what is there inside your repo, right? Is it a .NET app? Is it a Node.js app? Do we have a Docker file in there? And we actually use this information to show you the right next steps, right? So in this, for example, if you look at the suggestions that we have from Pipeline, you can actually do just ASP.NET CI. You can build your app. You can do a Docker CI. Or you can actually go all the way from here and deploy your app by using Azure Pipelines to a Kubernetes cluster, right? So let's take the hard path and select the AKS template we have here. Now, what's going to ask me is that I've said, OK, I want to deploy to Azure. So the first question, of course, is which subscription? So let's select the subscription. and go to the next step. Now, in the next step, what you see is the only information that we need from you to get started with deploying app to a Kubernetes cluster by using Azure Pipeline. So the information that we need is basically, we just need which cluster you want to deploy to and which namespace. And then followed by the container registry you want to actually build and push your image. So let's say I created a cluster yesterday for build demo. Let's select that. Now I have a choice. I can actually create a new namespace, or I can choose one which is existing. So let's create a new one. So let's say .NET app 1, and then select the registry here. Now that's all. That's the only information that we need from you, the cluster details and the container registry. The rest all we have already figured out. We have already populated a default image name. You can change it. We have also scanned the Docker file to find out on which port your application will listen to for traffic. So let's hit validate and configure. So now in this step, what we are doing is, we are actually generating the YAML file for you for Azure Pipeline without you knowing anything about Azure Pipeline, any of our YAML constructs. What we are also doing is we're actually connecting the Azure Pipeline with your container registry as well as the AKS cluster. And we are doing it in a very scoped manner. For example, we asked for the namespace. So what we are going to do is we are going to create a connection which is only scoped to that namespace. So this pipeline can only deploy to the namespace that you selected and not to any other namespace inside the cluster, right? So now we have this. It's a fully well-formed pipeline. It is actually something that you can just directly click save and run, and it will just work, right? And it has not only just CI, it has CD as well. So let's do that. And now you also see that we are also creating a couple of Kubernetes manifest files here, one for deployment and one for service. So I'll come back to the details of this later in the demo. Let's just hit save and run. What it's going to do is that it's actually going to commit these files, the Azure Pipeline YAML and the Kubernetes manifest files, to your GitHub repo that I showed you, and then it's going to trigger a pipeline run. So let's do that and switch to a pipeline that I created yesterday for this demo. So you see that the pipeline run has been successful. We completed the Docker CI. We were able to build and push the image to Azure Container Registry. And then we have this deploy job, right? And this deploy job also succeeded. So what are we doing in this deploy job? We are doing some of the basics right. Like, for example, we created an image pull secret. That is how your AKS cluster actually talks to your container registry and pulls down the image securely, right? We actually deployed to the Kubernetes cluster as well, and we looked for the rollout status. So we are not just like applying your manifest files, we're also looking for whether the deployment is successful and the rollout was successful or not, so that your pipeline run status actually reflects the exact status of your application. So now that we have got these basics right, we have been able to set up a pipeline without knowing anything about Azure Pipelines YAML structure. Let's switch to one more feature that we have. So we asked about like which cluster and which namespace. So what you see here is that we have actually created an environment for Kubernetes inside Azure Pipeline. And this is the cluster name and the namespace. So let's click on that. We deployed a simple app to start with. So we have one deployment workload running inside the cluster. So you can see that here. And we have one service which is exposing that particular application outside. So we can actually go to the external IP and test the application, whether it is working or not. See, this is the same app that John used some time back. And it is live, actually, and it is getting served from my AKS cluster. Now, there are a couple of interesting things that we have when it comes to the Kubernetes environment. When you're actually working with microservices, you will actually deploy, let's say, 5 or 6 or 10 different microservices to the same namespace in the Kubernetes cluster, right? And if things go wrong, how do you actually troubleshoot, right? So you need some critical pieces of information. One is like, what version of my app is deployed, which you get from looking at the image detail, right? Which image is deployed, that's the version of your app that you're running inside the cluster. You also want to know what is the status, whether the pods are healthy or not. And that also you get from this view. And you also know which pipeline run actually created these objects. So you can, from pipeline run, you can actually go back to your commit in the GitHub. You can actually go back to your work items, the bug fixes that you did, right? So you get complete end-to-end traceability. You can actually go one step deeper. You can look at your pod logs. And you can also look at the YAML that created these objects. For example, this pod was created by using this YAML. And here's one very interesting thing that we do when you use Azure Pipeline for deploying to Kubernetes. We actually annotate the CI/CD data to the objects that we created inside the cluster. So now this is not only useful for you when you actually use Azure Pipeline UI. If you're a command line user, you can actually run a kubectl describe command, and then you will exactly get the same annotations even in that in your console. So now from your console application, you can see which pipeline run, which git commit actually created this object, and then you can go and troubleshoot from there as well, right? So you get all of these features. If I just switch back to the slide again, so you get all of these features out of the box just by following a 3-step simple wizard, without knowing anything about any concept count around Azure Pipeline or knowing how to construct the Kubernetes manifest files. And now you can actually go and change the YAML, add deployment strategy, add approvals, whatnot, right? So thank you.
Thank you, Atul. So those are the basics. Now that we've got them kind of under our belt, let's go forward in time. And our application has grown. There's more team members that are coming on board as well. Now ramping up not only on the code base, but how we're doing our development and so forth. Maybe we're starting to get into microservices as well. Let me show you what the app looks like. Of where we've gotten. So this is an AdventureWorks cycles. You can see it's still a work in progress. We've got some test users here, which we use to be able to, just in our integration environment, be able to check out some of the app's functionality. We can log in, and you can see that there's a set of bikes that are available for me to be able to rent. And I can go in. I can select the bike. I can see some information, pricing, and so forth. I can see I want to rent the bike. And at some point, after I've used the bike, I go and return it. Confirm a return. I can rate my experience and so forth. OK, so development has gone forward here. What the app is starting to look like, and where's my clicker?
Yeah.
It's starting to look something like this, where we've got some individual services that implement some very specific business functions of the application. So there's a web front end that kind of holds the experience together. There's a reservation service, which is all about reserving bikes and returning them and so forth. There's the bikes service, which keeps a catalog of the bikes that are available. It has its own data store. There's the user service, which also has its own data store. So now I'm actually starting to get more moving parts in this application. It's all being developed incrementally. And what I'm starting to call like poly everything, where there's there's a lot of data services here. There's different services that are perhaps written in different frameworks or even different languages. And the dependency graph is actually starting to become more complex. And it actually isn't becoming feasible anymore to actually run this all on my dev machine. Right? I can't just run this whole thing. Now it's starting to get really bulky to be able to set this up on my dev machine. One of the things that we're seeing really is that microservices are really hard to develop locally. And so what I'd like to be able to walk you through is what could some steps or more traditional approaches that are applied to maybe monolithic apps, which now start to have new challenges start creeping in when you're taking more of a microservices approach. So let's say that your integration environment, where all your code meets and gets built and is deployed, let's say that's in Azure here. And you can see here's some of the services that make up our app. And let's say that I'm developing something somewhere in the middle, right? I'm not working on the front end. I'm not working right on the leaf node. That's something somewhere in the middle that has dependencies calling into it. It also has its own downstream services. So one way that I would go about it is, I've got my dev machine. I'm working on reservations, let's say. Well, before I can run reservations, I'm going to set up bikes, right? That's one of my dependencies at least. Bikes has its own data store, so I've got to set that up. Maybe it's Mongo, SQL, whatever. And so once I actually have those dependencies on my dev machine, at least at that point, I can actually now start to load the reservations project in my IDE and start modifying its code. Once I get it to the point where I've maybe coded up a feature or fixed a bug, I go check that in to source code control. That then kicks off some CI/CD pipeline, and now I've got stuff showing up in our integration environment. Okay, that sounds okay, but there's a few assumptions here that kind of hold true with monolithic apps, and not so true with as this application's architecture is moving. One is that I would actually know the full dependency graph. And we actually start seeing that that actually becomes less and less known. Even for this sample app that I'm showing you, I spoke with one of the devs on my team, which service calls which, and he kind of laid it out for me, and I went back to the code, and it actually was different. So he had actually worked on the services, but he was telling me something that wasn't quite right of how the application had progressed. So things are moving all the time. The other assumption is I know how to build and run everything, right? So the fact that I am depending on other stuff that other developers wrote in other languages, other frameworks, that is also not always the case. And lastly, I can run it all on my laptop. Now, there are various approaches that dev teams take to be able to just simplify what they have to work on. And one of them is just to create mocks. Instead of running the real billing service or reservation service, create a mock of that, and I'll just be able to use that on my local machine. But who can attest to at some point your mocks system actually ends up being more complex than your actual app? And now you're like, well, what do I maintain? Do I maintain my app, or am I maintaining my mock system and my tests and so forth? So that has its limitations as well. So one of the patterns that we're encouraging in AKS and Dev Spaces is the idea of having your baseline, your dev integration environment in a shared AKS cluster. Okay, so that's running maybe the version of everything that's checked into master. And so one of the developers comes along and says, well, I'm the front-end developer. And you create a little space for yourself. Really, that's just a namespace in Kubernetes. And you run from using your VS or VS Code or a CLI, you run just the service that you're interested in running. And the fact that it's actually running in AKS now, well, instead of creating all the other bits, all the entire application, you are able to leverage the services that are running in the shared AKS cluster. This is, you can run as many of the services as you want. So if you're modifying a little bit of code in the front end, a little bit of code in reservations, or run your own versions there. But everything else, you're always able to test it in the context of the end-to-end application. So that's the front-end developer. What about someone who's maybe working on something in the back end? The same kind of thing. You can still use the same AKS cluster. You carve out your little space here, in this case, John's space, and you run the bike service. The bike service is connecting to some data store that's running in the cluster or in Azure. And just as always, maybe that's a REST API, and you can directly test that. But what you would also like to do is be able to just test this end-to-end, right? So you would be able to also have the ability to be able to call the front end, which calls reservations, but then be able to direct the request and say, well, don't call the team's baseline of bikes, call my version of bikes. And that way you're really able to see before you commit your code, before you're ready to be able to go CI/CD and deploy and so forth, before you're wrecking the build, right? You're able to work in isolation. You're not messing up anyone else's work, but you're also able to test end-to-end in that world. So to be able to make this gel a little bit more in a concrete way, let me just switch back over to the application here. So we all saw the application before. This is the mono repo that actually has all of our source. You can see I've got different folders for the different services, my bike service, my billing service, where my databases are. And inside the Kubernetes dashboard, you can see that these are all my individual services that are running. Now, going back to the application here, you can see that I can open up a bike's details, and I can rent it, as we saw before. I can return it. OK, good. I've been called in because there's a bug that seems to affect some of the bikes that, when someone goes to try and rent it, we're seeing that there's an error. So let me show you that. I'll pull up another bike over here, and I try and rent it, and I get an error. Well, that's strange. I was able to rent something else before. How about this one over here? Well, I can rent that one. So there seems to be something very specific about each bike. Sometimes I get an error, sometimes I don't. And I haven't been working on this project for a while. The dev team has ramped up on that. But I've been called in, maybe to fix my first bug. So let's go back over to the code here. And what I do here is, if I'm investigating a particular bug, and let's say that we have a suspicion that it has to do with the bike service. Okay? So here I've got VS Code open up on just that service. In this case, bikes. And I don't have to go and try and set up the whole world to be able to understand what are the dependencies. I just want to be able to troubleshoot this, set a breakpoint, being able to see what's going on. So one of the commands I can write here is AZDS space select. And what this is going to show me is what are all the spaces or the dev spaces that are available in that cluster. And you can see, well, there's a bunch of things here. There's something like master. There's several folks here. There's also like feature branches, it seems, that are showing up here. I'm going to just choose my own here. So I'm running in a dev space called John. And then I'm just going to hit F5 here. And as you saw before, that's going to sync my code to the AKS cluster, just in my own isolated space. It's going to build this service in a container, deploy it. We give it a few seconds to be able to do that. Says that it's connected to the database, which is actually running in the cluster. I didn't have to set that up. Now, if I go over here, and I can be refreshing this page, but look what happens when I prefix the URL. It might be a little bit difficult for you to see, but all I need to do is type in the name of my space, in this case, john.s, and then the rest of the URL. And when I do that, the web front end is calling the reservation service and so forth. It's making a few requests. Finally, when it makes a call to the bike service, it touches my version of bikes. So now I'm able to hit some breakpoints. Here it seems like it's trying to get all available bikes. It's hitting the Mongo database. And it's about to return all the list of bikes that you saw on the page here. And I can just inspect these objects. I can see that's one of the bikes over here. And as I go through, some things are kind of a little fishy already. It says available is false, but it's actually showing up on a page where it says this is available to rent out. And that's probably the cause of the issue here. In fact, I've got a little comment out here. This is probably where the bug is. Wouldn't it be great if you could actually fix all of your bugs just by uncommenting code? This is my lucky day. So what I did is I modified some code, I hit save, and immediately that actually updated the container in AKS. I'll refresh this page. I hit my breakpoints again, hitting the database. And now I've got less bikes returned. That kind of makes sense to me. And you can see that all of them are actually available as true, which is good. All right, I think I am and I'm displaying less bikes here. I think these are the ones, that was the problem. It was just a one-line fix, which is good. So are we good to check this into master?
No, that's not how you develop microservices, right?
Oh, really?
Yeah, you create a feature branch.
Okay. Not into master. You don't trust me?
No.
Okay. All right. Okay. Okay, so let's get out of this. I've got my code change over here. So you're saying I need to work out of a feature branch.
Yep.
So I am currently in master. That's a good thing that I didn't commit. Okay, so I'm going to change that. I'm going to check out this was the number of the bug. So I'm just going to call the branch that. Okay, so I've switched over to a branch here, fix bug. I'm going to commit that, and then I'm going to push. And this is the first time I'm creating a new branch in GitHub. So off I go. I've done my work.
Okay. Thanks, John. So. So this was one of the fastest bug fixes that I've seen in my career as a developer, right? And I really don't trust this bug fix. So what can we do actually to verify that? I mean, we can actually do what we can do is like we can do a PR, and then we can do ask him to write some unit test cases, or maybe we can just go and do a static code review, right? But we are actually living in this era where we have Azure Pipelines, we have Azure Dev Spaces, we have AKS cluster, right? So how can we push the boundary and actually take it a bit further and see how we can actually verify the changes that John has done and make sure that whether it works or not, right? So that's where the demo that we actually show you, we are going to show you, it comes into picture. But before I start that, let's create a PR first, right?
Okay.
For you.
So that's the way we're doing things?
Yeah. So let me switch to my system. So here we have this same GitHub repo. What I'm going to do is actually create a new pull request. Here, which was the branch that you? Yeah, it's there. We just changed the base repository to the same thing. And now we have the feature branch in which John made the change. So we'll just select that.
All right, that's my commit there.
Yeah, you can see the change that he made. Really complex one at that. Now I'm going to do fix AB hash 139, and I'll talk about it later why I'm using this term. And then fixed the bug, right? Simple. And I'm going to create a pull request. So now I'll switch to the slides to explain a bit about the demo that we have. Yeah. So this slide does a good job of explaining that. So what we are going to do is like we have this Azure pipeline set up. So whenever you make a change to your master branch, we are going to actually deploy all the microservices that are there in the in that master branch to namespace called master in the AKS cluster. So you have, let's say, 5 microservices. You make a change to, let's say, reservations, and you commit it to, you push that change to your master branch. The pipeline will trigger, and it will deploy. So in the master namespace, you always have the latest and greatest of all your microservices available all the time, right? Now, the next step is what basically John did. He actually created a feature branch, and he pushed his changes into that feature branch. Now, what we're going to do is, the moment there's a pull request that has been created against the master branch, we are going to trigger another pipeline, which is going to create another dev space inside the same AKS cluster and deploy the changes that John did into that particular dev space. Now, this actually lights up a few very interesting scenarios. Like one is like you can actually go and test the changes against the latest and greatest of the other microservices on which you have a dependency. So if I have to test bikes, my changes of bikes, I'm actually able to test it against the reservation service, against the database that we have in the master dev space inside the cluster, right? So this is the setup that we have done. So let's take a look at the YAML file which actually powers this now. Let me switch to my laptop again. Yeah. So if you see here, there are a few interesting things here. One is that we have this path filter. So what I'm doing is, this is a mono repo scenario. So all the microservices are basically inside the same repo. But I don't want to actually build all of my app when I make a change to just one microservice, right? This is where this filter comes into picture. Now, this pipeline will run only when I make a change to bytes, right? The second is, we have few stages here in the pipeline. If you see, we have a build stage, which is always going to run because we are going to build our container and push it to a container registry. And then we have a stage called deploy to master, and then we have a stage followed by, which is called deploy to PR. Now, if I just expand deploy to master, you see we have this condition here, which ensures that this particular stage in the pipeline will run when you actually make a change to master branch. So in this stage, what we are doing is we are just simply taking the Kubernetes manifest files or Helm chart, right? In this case, it's Helm chart that Azure Dev Spaces created for us earlier in the demo. And we are just going to deploy it to the cluster. So every time you do a change to master, it's going to get deployed to the master namespace inside the cluster. Now, the second stage that we have is actually deploy to PR, and that is where things get interesting. What we are doing here is, we are actually, we again have a trigger, we have a condition that this particular stage will only trigger when we actually have a pull request for master. And this is going to do a couple of things. One, it's going to create a dev space. So all these steps that you see here are responsible for creating a new dev space inside the cluster. And the next couple of steps are going to actually take the latest changes that we have made to our application and then deploy it to the new dev space that we have created, right? So I think by this time, our pipeline would have finished. So let me switch back to the pipeline run view. I'll go to the bike sharing sample app right here. So you see, this actually just finished some time back, today at 1:13, so just a couple of minutes back. Build stage completed. It skipped the deploy to master because it's a PR. It didn't deploy to master. In the deploy to PR review app, if I click, you see that we have actually created the namespace, and we have gone and actually deployed the app to that particular namespace. So now let's open the PR that we created, right? This PR is in GitHub. And here, you see that we have actually passed all the checks. So what we are doing here is like, we have this nice integration between Azure Pipeline and GitHub. So whenever you have some stages which are getting completed in Azure Pipeline, we are actually going and writing it back to GitHub. So from your GitHub PR view, you can actually see all the steps that we have taken inside Azure Pipeline. So for example, I can go click on details of this particular stage, and you see that this actually ran successfully. I can actually go and click on the link here, and this will actually directly take me back to the pipeline run that we actually ran to deploy this app, right? And from Azure Pipeline, we can again go back to the same PR, right? So this is a very nice integration that we have in, between both GitHub as well as Azure Pipeline. Now, there's one more thing. We have one line which says dev space review app is up, right? And we have this details here. So we click on that, and what it does is it actually opens up the version of code change that actually John created a PR for, right? So you can see that it is actually, it got a prefix, which is fix 139s. This is the branch name that we had, right? So now we have opportunity to actually really test whether your fix works or not.
All right? You're putting me on the spot.
Trust but verify.
So we have this master version of the app here, right? You can see it is showing a lot of bytes. Some of them are reserved. And here is the version that John has, right? So let's click on that and see whether it works or not. So it actually works, right? So now we have actually verified against a live environment by testing it against the master version of each of the other dependent services that actually the fix that John did works. So great job, John. A round of applause for John.
I'm glad we raised your confidence.
Yeah. So now that we are super confident about the bug fix, what we can do is we can actually go back to the GitHub. Let me just navigate back to that. And we can actually merge this PR into master now. So we have the bike sharing app, and it has an open PR. So we are going to actually say, OK, this looks good. Everything is green. So we merge the pull request. Confirm the merge. Now what it's going to do is it's actually going to trigger a new pipeline run, which is going to actually deploy this version of the app into the master namespace so that the fix that John made is actually live now. We can actually go to pipeline and confirm whether the pipeline has been triggered or not. You see it has been triggered. And there's one more thing that we did. We actually had a bug open in mining. And the moment we actually merged it to master, this bug should actually get resolved, right? So it got resolved. So we have fixed the bug as well. And you get complete traceability for like what happened in this bug right from this view in the boards as well. So we've done the complete end-to-end bug fix, John, right? Look good?
Yep.
Okay.
The bug is in your name, though. It looks like you checked in the fix. And
Welcome to the team.
OK.
Yeah, so that's about it. That was a demo all about. Like, over to Sean.
Cool. So when I left the stage, Kubernetes was super complicated, and we didn't know how to approach it as developers. Do people feel like it's a little bit more approachable now with the tools that we talked about? Awesome. That's exactly the goal. Yes, of course. Don't be shy. So again, the idea here is by virtue of taking tools like Dev Spaces and Azure Pipelines and actually combining them together as a tool, and John showed, I can actually accelerate forward to the place where I can take advantage of all the power of Kubernetes as a microservices platform. Right now that app is deployed into production, I can scale those individual services, I can upgrade them independently, I can get all of that value that Kubernetes is providing, but I've been able to build and debug those services as a developer. And so the interesting thing about the capability that we showed here, and particularly the last part, is actually something that we developed as part of building out this session. The original intent of the session was to kind of show these as two services side by side. And then this notion of having dev spaces play as part of the pipeline and creating this dev space associated with the pull request is something that we sort of developed as part of building the session. And I think now the intent is to make this into like a first-class capability, so that all of that YAML that a tool showed is kind of just a first-class feature of the service. So this is a really interesting way of bringing these concepts together. So hopefully you feel like, and it sounds like people do feel like it's a little bit easier now to get started and to progress through to building real-world applications. And we hope that you're going to do that on AKS. So thank you very much.